Welcome to Creative Civil Engineering Coach. In this video, I'll be discussing about PGCET Civil Engineering question paper of the year 2012. Let's begin with the part 1 questions. Question number 1. When a cantilever beam is subjected to all over UDL. Consider a cantilever beam AB of a span length L subjected to UDL load of W kN per meter throughout the span. So, here you can observe the maximum deflection is given by WL to the power of 4 8 EI, and this is the corresponding shear force diagram and bending moment diagram, where you can observe the intensity of shear force is 0 at the free end and maximum at the fixed end with WL intensity. Similarly, the bending moment is also maximum at the fixed end with the intensity of minus WL square by 12. So, both shear force and bending moment are maximum at the fixed end. Option B is the right answer. Question number 2. Which of the following formula is the prismoidal formula for calculating the capacity of contours? To calculate the capacity of contours, there are 3 different types of formula, as you can see in this picture. Consider a contour profile with a different cross-sectional area A1, A2, A3, where H is the equal contour interval between the successive areas. So the volume of the contours is calculated by the prismoidal formula from the following equation. Option B is the right answer. Question number 3. A beam column is a structural member that is subjected to axial compression and transverse bending at the same time. It is a column subjected to axial load and moments or transverse load. In the following figure, you can observe a beam column section. Option A is the right answer. Question number 4. Forces in the legs of a tripod stand is an example for. In the following figure, you can observe a tripod with 3 different legs A, B and C, and this is the corresponding free body diagram for the tripod. So let's consider a free body diagram of a tripod stand with the 3 different forces F1, F2, F3 along the legs of a tripod stand A, B and C respectively. This following figure represents non-coplanar concurrent forces because all these forces F1, F2 and F3 passes through the same point. However, they are in different planes. So, the right answer is concurrent and non-coplanar forces. Option B is the right answer. Question number 5. If the jam density is given as Kj and the free flow speed is given as UF, the maximum flow for linear traffic speed density model is given by which of the following options? As per green shield model theory, the maximum flow is given by maximum density and maximum velocity, where maximum density is given by half of jam density and maximum velocity will be half of the free flow speed. So the maximum flow will be 1 by 4 times of jam density and free flow speed of the vehicle. Option A is the right answer, 1 by 4 of Kj into UF. Question number 6. Isoid is a line joining. Isoids are the line joining points of equal rainfall for a given interval. So in isoids, the line joining the points on a map where amount of precipitation recorded in a given period is same. Option B is the right answer. It represents the point of equal rainfall. Question number 7. Transition curves are introduced in highway specifically to cause. Transition curves are designed to prevent sudden changes in the lateral or centripetal acceleration, and it is governed by rate of change of radial acceleration and rate of change of super elevation. So, transition curves are introduced in highway specifically to cause change in direction. Option A is the right answer. Question number 8. Traffic volume is defined as the procedure to determine the volume of the traffic or number of vehicles moving on the roads at a particular section during a particular time period. So, traffic volume represents the number of vehicles in a stream per unit length of the stream. Option B is the right answer. Question number 9. In California bearing ratio test, pressure sustained by specimen corresponding to CBR for 5 mm exceeds that for 2.5 mm, the test should be repeated, and if the identical results are shown, the CBR for 5 mm penetration should be taken for design. So the right answer is option C. Question number 10. The specific gravity of most of the building stone lies between. The specific gravity of a building stone lies between the range of 2.5 to 3. Most appropriate answer will be around 2.3 to 2.5. Option C is the right answer. Question number 11. Which of the following method is not used to improve the bearing capacity of soil? Option A. Compacting the soil. If we compact the soil using appropriate method, then there will be increase in density and shear strength. So, option A is true. Option B. Confining the soil. In this method, the soils are enclosed with the help of sheet piles. This confined soil is further compacted to get more strength. So, this method is also true. Option C. Pressure grouting. This method is applicable for soils where there is a presence of pores, fissures or cracks, etc. underneath the foundation. In this method, poor soil bearing strata is hardened by injecting the cement grout under the pressure. So, this method is also true. Option D. Acid treatment. Acid treatment is the addition of organic or inorganic acids which results in decrease in pH, which efficiently prevents the growth of microorganisms. So, this method cannot be used to improve the bearing capacity of the soil. This option is false. So, by this method, the bearing capacity of the soil cannot be improved. So, the right answer is option D. Acid treatment. Question number 12. Non-carbonate hardness. Non-carbonate hardness is the hardness which is caused due to chlorides of calcium and magnesium and sulfates of calcium and magnesium. Non-carbonate hardness is also called as permanent hardness as it can be removed only through chemical methods. Carbonate hardness will be equal to total hardness in excess of alkalinity. Question number 13. Minimum grade of concrete recommended by IS 456-2000 for RCC work is. As per IS 456-2000 for RCC work, the minimum grade of concrete recommended is M20 grade with a mixed ratio of 1:1.5:3, which means that 1 part of cement, 1.5 parts of fine aggregate and 3 parts of coarse aggregate. So, the right answer is option A, M20 grade concrete. Question number 14. In limit state method of design, limiting value of the path of neutral axis when Fe415 grade steel is used is equal to. As per IS 456-2000 codal provisions, the ratio of limiting depth of neutral axis to its effective depth of the beam is calculated by the formula. Therefore, XU is equal to K into effective depth of the beam, where K represents the limiting value. In the following figure, you can observe for different grades of the steel the limiting value. So, for 415 grade steel, the limiting value is 0.48 times of effective depth. Option B is the right answer. Question number 15. In most economical rectangular section of a channel, depth is kept equal to. Most economical section is the one whose wetted perimeter is minimum for given value of the discharge. For minimum wetted perimeter, the depth of the water should be half of the width. So, the right answer is option C, half of the width. Question number 16. Which of the following statement is correct? In this question, all these options are regarding Atterberg limits of a soil, and these Atterberg limits are the basic measure of a critical water content of a fine-grained soil. Depending on its water content, the soil may appear in one of the following states, as you can observe in the following picture. Option A. The moisture content at which transition from solid to semi-solid takes place is defined as shrinkage limit. This statement is true. Option B. The moisture content at which point of transition from semi-solid to plastic state is called shrinkage limit. This statement is false because this point of transition is plastic. Option C. The moisture content at which the point of transition from plastic to liquid state is called shrinkage limit. This statement is also false because the point of transition from plastic to liquid state is called liquid limit. Option D. The moisture content at which a point of transition from solid to liquid state is called shrinkage limit. This statement is also false. So, the right answer will be option A. The question number 17. As per IS 1172-1983, minimum domestic water consumption for Indian towns and cities with full flushing system is population or communities with 20,000 to 1 lakh. The minimum water consumption with the full flushing system is 100 to 150 LPCD. And if the population or communities is greater than 1 lakh, the minimum water consumption with the full flushing system will be 150 to 200 LPCD. So, the right answer is option A, 200 LPCD. Question number 18. In order to avoid tendency of separation at throat in a venturimeter, the ratio of diameter of throat to the diameter of the pipe should be. In the following figure, you can observe a venturimeter So the throat dia will be 1/3 to 1/4 of inlet pipe dia. Question number 19. Burden pressure gauge measures. In the following figure you can observe burden pressure gauge where it measures the gauge pressure of liquid, fluid and gas at gauge point. So option B is the right answer. Gauge pressure at gauge point. Question number 20. As per IS 456-2000, normal cover requirement for steel reinforcement in beams designed with M25 grade concrete exposed to moderate condition shall be. So in the following figure you can observe the minimum grade of the concrete and the nominal cover requirement based on different exposure conditions. So the minimum cover requirement will be 30 mm. Option C is the right answer. Question number 21. Which of the following chemical formula represents the Bogue compound silicate in cement? The Bogue compounds of cement are tricalcium silicate, dicalcium silicate, tricalcium aluminate and tetracalcium aluminate. In the following you can observe its common name and its chemical formula. The Bogue compound silicate is also called as tricalcium aluminate with a chemical formula 3CaO Al2O3. So option C is the right answer and this should be Al2O3. Question number 22. Which of the following gives equilibrium conditions for coplanar concurrent forces? In the following figure you can observe a coplanar concurrent force system. Coplanar concurrent force are those forces which meet at one point and their lines of action also lie in the same plane. So the equilibrium conditions for this type of forces are force along x-axis and force along y-axis is equal to 0. Option D is the right answer. Question number 23. Water absorption of first class bricks in 24 hours will be. The water absorption for first class bricks in 24 hours shall not exceed 20% of its dry weight. For second class bricks 22% and for third class bricks it should not exceed 25% of its dry weight. Question number 24. If fore bearing of a line is north 30 degree east, then its back bearing. Its back bearing will be south 30 degree west. Option A is the right answer. Question number 25. As a liquid flows in a convergent pipe, the velocity increases in the direction of the flow according to principle of continuity, while the pressure decreases according to Bernoulli's theorem. So the right answer is option D. Question number 26. In IS method of design of two-way slab, the length of the middle strips along both directions is equal to. In the following figure you can observe a two-way slab which is divided into one middle strips and two edge strip. Middle strip is of 3/4 of respective length and two edge strips are 1/8 of respective length in either directions. So option A is the right answer. Question number 27. Uniformity coefficient for sand used in slow sand filters should be in the range of. For a slow sand filter, the uniformity coefficient of a sand is 1.8 to 3. The answer is option B, 1.2 to 1.8. And the remaining parameters of slow sand filters and the rapid sand filter you can observe in this following picture. Number 28. A simply supported beam is subjected to a uniformly distributed load intensity W per unit length on half of the span from one end. The length of the span and flexural stiffness are denoted as L and EI. The deflection at the midspan of the beam is. So the maximum deflection is minus WL cube by 192 EI. The calculation is as follows. Question number 29. King post truss is used for the span range of. King post truss is a central vertical member of a roof truss, as you can observe in this following picture. King post is used to support the weight of an expansive roof and span ranging from 5 to 8 meter. So in the given options, the appropriate answer will be 6 meter to 9 meter. Option A is the right answer. Question number 30. Which of the following statement is false? Option A. Unit hydrograph of a T-hour duration is the hydrograph of direct runoff from the given catchment due to a rainfall excess of 1 cm occurring over T-hour duration. This statement is false because unit hydrograph is a hydrograph with a volume of 1 cm runoff resulting from a rainfall of a specified duration and a real pattern. So this statement will be false. So the right answer is option A. Question number 31. The cross section of thermomechanically treated reinforcing bar has. Thermomechanically treated bars are subjected to atmospheric cooling to equalize the temperature difference between inner and exterior core. Once TMT bar cools down, it slowly turns into ferrite perlite core with a hard martensitic rim. So option C is the right answer. Question number 32. In a symmetrical I-section beam, shear stress is maximum at. In the following figure, you can observe a symmetrical I-section beam is given with the corresponding shear stress diagram, where the maximum shear stress is always occurring at the outermost fiber, that is at neutral axis. So the right answer is option C. The maximum shear stress will be occurring at neutral axis. Question number 33. Likelihood of general shear failure for an isolated footing in sand decreases with. In the following figure, you can observe the general shear failure pattern for an isolated footing in sand, where it has a well-defined failure pattern and the failure is sudden by tilting of foundation. Here you can observe the bulging of ground surface adjacent to the foundation, and this type of failure occurs in soil of low compressibility. So if the intergranular packing of sand decreases, then the sand will behave as a loose sand, hence likelihood of general shear failure will decrease. So the right answer is option B, by decreasing the intergranular packing of sand. Question number 34. Torsional rigidity of a shaft is given by. The general torsion equation of a shaft is given by the following formula: T by J tau by R is equal to G theta by L. So TL by theta is equal to G into J. So the torsional rigidity of a shaft is the product of rigidity modulus and the polar moment of inertia. So the right answer is option D. Question number 35. Saturated density of a soil is calculated by using the relation. When the soil mass is saturated, its bulk density is called saturated density, and it is given by the following formula: Gs plus E into bulk density divided by 1 plus void ratio. Option A is the right answer. Thus, saturated density is the ratio of total weight of saturated soil sample to its volume. Question number 36. Kinetic energy correction factor when the flow is turbulent is equal to. The kinetic energy correction factor is defined as the ratio of kinetic energy per second based on actual velocity to the kinetic energy per second based on average velocity. So, for a turbulent flow, the kinetic energy factor is 1, and for laminar type of flow, the kinetic energy correction factor will be 2. As it is asked for turbulent flow, the correction factor will be 1. Option B is the right answer. Question number 37. Frod's number of a flow is given by. Frod number is the ratio of inertia force and gravitational force. So, option B is the right answer. Question number 38. Contour interval is. Contour interval is a vertical distance or difference in elevation between contour lines. It is always kept the same or constant for a map. This contour interval depends upon scale of the map, purpose of the map, nature of the ground, time and cost, and slope. So, contour interval is defined as the vertical distance between two consecutive contours. Option B is the right answer. Question number 39. Which of the following is not a method of plane tabling? In plane table surveying, radiation, intersection and traversing are used, but backsight is a method of orientation. So, option C is the right answer, backsighting. Question number 40. The basic LYD ratio to control deflection of a simply supported beam up to 10 meter is. As per IS 456-2000 from the clause 23.2.1, deflection can be limited by controlling the span to effective depth ratio as given in the following table. So, for a simply supported beam, the basic LYD ratio is 20. Option C is the right answer. Question number 41. Minimum tension reinforcement in a beam is given by. As stipulated in the clause 26.5.1.1 A and B, the minimum amount of tensile reinforcement shall be at least ASD by BD is equal to 0.85 by Fy. Option A is the right answer. Question number 42. The effective length of a column whose one end is fixed and other end is hinged. As per IS 800-2007, the effective length of a column for one end fixed and other end hinged is 0.707 times of length of column. Option C is the right answer. Question number 43. In a thin cylinder subjected to fluid pressure. For a thin cylinder vessel, the hoop stress is given by PD by 2T, where P is the fluid pressure in Newton per meter square, D is the diameter of the cylinder, T is the thickness of a cylinder, and the longitudinal stress is given by PD by 4T. So if you calculate the ratio of hoop stress and longitudinal stress, hoop stress will be 2 times of longitudinal stress. So the right answer is option D. Question number 44. In a closed traverse. In this following picture you can observe, for a segment AB, latitude is equal to L cos theta and departure is equal to L sin theta, and summation of latitude is equal to 0 and summation of departure is equal to 0. So the right answer is option B. Question number 45. In the UDL region of a simply supported beam, which of the following conditions are satisfied? Let's check the following conditions whether it is true or false. Option A. Shear force is maximum where bending moment is maximum. This statement is false because shear force is minimum where bending moment is maximum. Option B. Bending moment is maximum where shear force is 0. This statement is true. Option C. Bending moment and shear force are numerically equal. This statement is false because bending moment and shear force are not numerically equal. Option D. Shear force variation is parabolic. This statement is also false because shear force variation is linear. So the right answer will be option B. Bending moment is maximum when shear force is 0. Question number 46. In leveling work, arithmetic checks are used to. Arithmetic checks are used for the checking the correctness of computations. Option B is the right answer. Question number 47. In plastic analysis, the ratio of plastic moment to the yield moment is called. The ratio of plastic moment to the yield moment is defined as shape factor. Option C is the right answer, where the shape factor is the ratio of plastic section modulus to elastic modulus of the section. Question number 48. Dead storage in a dam is. In the following figure you can observe the different storage zones of a water in the dam. So this is the dead storage, which is a volume of water stored below minimum pool level. Option A is the right answer. Question number 49. If P is the maximum load on the cylindrical specimen of a diameter D and length L in a split tensile strength test, then the split tensile strength is given by. Split tensile strength is 0.66 times of modulus of rupture. So it is calculated by the formula T is equal to 2P by dl, where P is the maximum load on the cylinder, D is the diameter of the cylinder, and L is the length of the cylinder. So option B is the right answer. Question number 50. On Mohs scale, hardness of quartz is. Hardness is measured by scratching the mineral with a series of substance of a known variation. So the hardness of quartz will be option C. In the following table you can refer the different hardness of minerals. So this completes the part 1 questions of this question paper. Now let's begin with the part 2 questions. Question number 51. If the standard atmospheric pressure is 760 mm of mercury, then the same expressed in meters of water is. The basic pressure equation is given by the following formula. P is equal to rho GH. The pressure in pascals 101325 pascals. Rho is the density of water 10,000 kg per meter cube. G is the acceleration due to gravity 9.81 meter per second square. H is the height of the fluid or liquid shown against the pressure. If you substitute these values in the basic pressure equation, the height of the water shown against the pressure will be 1.0333 meter. Option C is the right answer. Question number 52. In a thin cylinder of diameter 1000 mm and thickness 10 mm, it is subjected to a fluid pressure of 1 Newton per mm square. Then the hoop stress in the cylinder will be. Hoop stress is calculated by the formula PD by 2T, where P is the fluid pressure 1 Newton per mm square multiplied by 1000 mm is the dia divided by 2 into 10 mm. T is the thickness of the fluid. So the hoop stress will be 50 Newton per mm square. Option B is the right answer. If the latitude of a line AB shown in the figure is 100 meter northing, then the departure is. So here the latitude value is given, that is 100 meter northing, and the angle between the line segment AB is 60 degree. We know that latitude is equal to L cos theta. Latitude is 100 meter northing, so 100 is equal to L into cos 60 degree. So the length of the line segment AB is equal to 200 meter. To find the departure, we know that departure is equal to L sin theta. So departure is equal to 200 into, so departure will be 173.2 meter eastern. So the right answer is option A. Question number 54. If the equation for bending moment at a section in a beam is equal to mx is equal to 50x minus 10x square, then the equation for shear force in the section is. The equation for shear force in the section will be calculated by the formula differentiation of bending moment at section x. So differentiation with respect to x is equal to 50x minus 10x square, which is equal to 50 into x square by 2 minus 10 into x cube by 3, which is equal to 25x square minus 10x cube by 3. So the right answer is option A. Question number 55. If the volume flow rate through a pipe is 10 meter cube per second of a liquid with a specific gravity 0.8, then the mass flow rate is. Mass flow rate is calculated by the formula rho into specific gravity into volume of the flow rate. So density is 1000 multiplied by specific gravity multiplied by volume of the flow rate is 10 meter cube per second. So the mass flow rate will be 8000 kg per second. Option A is the right answer. Question number 56. If the area of the main reinforcement required for one-way slab is 334 mm square, then the spacing of 8 mm dia as per IS 456-2000 is. Spacing is calculated by the following formula. So it is the ratio of AST provided by AST required, which is equal to 0.150 meter. So the right answer is option A, 150 mm. Question number 57. In a leveling work from as an instruction position, staff readings were taken on link and bottom of sledja. The readings were respectively 1.5 meter and 1 meter. The second reading being taken with the inverted staff. So we have to find the difference in elevation between these points. Difference in elevation between these two staff reading points is equal to, the first reading is 1.5 meter, which is taken on a normal staff, that is on link, and the second reading is, it is taken on the bottom of sledja, so it is minus of 1 meter. So the difference in between these 2 points is 2.500 meter. Option B is the right answer. Question number 58. If the velocity of the flow in the pipe of diameter 0.15 meter is 0.0452 meter per second, if the kinematic viscosity of the fluid is 1.8 into 10 to the power of minus 5 meters square per second, then the Reynolds number is calculated by the formula Vd by mu, where V is the velocity of the flow, that is 0.0452, and D is the diameter of the pipe, 0.15 meter, divided by kinematic viscosity of the fluid, that is 1.8 into 10 to the power of minus 5 meters square per second. So if you calculate this, the Reynolds number will be 376.66. Since the Reynolds number is less than 2000, the flow is considered as laminar flow. So option B is the right answer. Question number 59. The intensity of active earth pressure at a depth of 10 meter in a dry cohesionless soil with an angle of internal friction 30 degree and unit weight of 15 kN per meter cube. So we have to find the intensity of active earth pressure, which is equal to coefficient of active earth pressure multiplied by unit weight of a soil multiplied by h square, where h is the depth or height. Therefore, the intensity of active earth pressure will be 50 kN per meter square. Option B is the right answer. Question number 60. The super elevation needed for a vehicle traveling at a speed of 60 kmph on a curved path of radius 128 meter on a surface with a coefficient of friction is 0.15 meter. So we have to find the super elevation needed. As per ARC, we know that E is equal to V square by 127 R minus coefficient of friction. Therefore, the rate of super elevation will be 0.0714. Since the maximum rate of super elevation is restricted to 0.07, the right answer is option B, 0.07. Question number 61. If the resultant of two equal forces is equal to magnitude of forces, then the angle between the force is equal to. We know that the resultant force is equal to F1 square plus F2 square plus 2F1 F2 into cos theta. Since the resultant of force is equal to two magnitude forces, F square is equal to 2F square plus 2F square cos theta. So cos theta is equal to minus 1 by 2. Therefore, theta is equal to 120 degree. Option A is the right answer, 120 degree. Question number 62. For a two-lane urban road with a one-way traffic has a maximum capacity of 1800 vehicles per hour. Under the jam condition, the average length occupied by the vehicles is 5 meter. The speed versus density relationship is linear. For a traffic volume of 1000 vehicles per hour, the density in vehicles per kilometer is. Jam density is given by maximum density of the vehicles divided by average length of the space occupied. So 1000 divided by 5 is equal to 200 vehicles per hour. We know that the maximum flow of a traffic is given by 1 by 4 of jam density into free flow speed. Maximum flow for a one-way traffic is 1800 divided by 2 is equal to 1 by 4 of jam density is 200 vehicles per hour. UF is the free flow. So the free flow of the vehicles is 18 km per hour. For one lane condition, the flow will be 1000 divided by 2, which is equal to 500 vehicles per hour. Therefore, U is equal to 18 minus 18 divided by jam density 200 vehicles per hour into density of the vehicles. On solving this equation, you will get the density of the vehicle as 33.33 vehicle per kilometer. So it is asked for two-lane traffic condition. So the density will be 2 into 33.33 vehicle per kilometer, which is equal to 67 vehicle per kilometer. So the right answer is option C. Question number 63. If the whole circle bearing of a line is 45 degree, then its back bearing in the quadrantal system is, this is 45 degree, which lies in northeast quadrant. So its back bearing will be south 45 degree west. Option B is the right answer. Question number 64. The value of W that results in the collapse of a beam shown in the adjoining figure and having the plastic moment capacity MP is. So this is a very tedious process. I'll just display the calculation and the procedure to determine the value of W. You can go through this. So the plastic moment capacity of MP will be 13 by 21 MP. Option D is the right answer. Question number 65. The ratio of Euler's critical load of a column with both ends fixed to that of column with both ends hinged with all the other variable being same S. We know that the Euler's critical load is calculated by the formula n square pi square EI by L square, where n is the factor depending on the end conditions of the column. N is equal to 1 for both end fixed and n is equal to 1 by 2 for both end hinged. Euler's critical load for both the end fixed is equal to, which is equal to pi square EI by L square, and the Euler's critical load for both the ends fixed is equal to pi square EI by 4L square. So the required ratio is, the ratio of critical load for a column with both end fixed to the rough column with both end hinged with all the other variable being the same is option B. Question number 66. A section of meter gauge railway track has 4-degree horizontal curve and a gradient of 1 in 200. The total resistance to traction due to gradient and curvature of the track is. Total resistance due to traction is equal to 0.02% of degree of curve, which is equal to 0.62% of weight of train. Right answer is option C. Question number 67. In an experiment, positive and negative values are equally likely to occur. The probability of obtaining at most one negative value in 5 trials is. So to obtain the probability of r numbers of successive in n trials is given by the general formula P of x is equal to NCR P to the power of r Q to the power of n minus r, where P is the probability of getting negative value and Q is the probability of getting positive value. Since positive and negative values are likely to occur, P is equal to Q. That is, P is equal to Q is equal to 1 by 2. So, for at most negative value or negative value in 5 trials, P is equal to R less than or equal to 1, which is equal to P of R is equal to 0 plus P of R is equal to 1, which is equal to, so the probability of getting at least one negative value in 5 trials is 1 by 32 plus 5 by 32, which is equal to 6 by 32. Question number 68. A rectangular beam section is subjected to bending moment of 156.25 kN meter. If the moment of inertia of the section about the neutral axis is 1.60 into 10 to the power of 9 mm to the power of 4, then the tensile stress developed at a distance of 100 mm from the neutral axis is. From the bending moment equation, we know that m by I is equal to sigma by y is equal to E by r. So to find the maximum bending stress, sigma is equal to m by I into y. So the maximum bending stress will be 9.76 Newton per mm square. So the right answer is option B. Question number 69. If a rectangular beam of cross section 300 mm by 400 mm is subjected to a shear force of 50 kN, then the maximum shear stress in the section is. Maximum shear stress for a rectangular beam is 3 by 2 of average shear stress. So average shear stress is the ratio of shear force 50 kN, so 50 into 10 to the power of 3 divided by area of the rectangular section, that is 300 by 400 mm. So the maximum shear stress will be 0.625 Newton per mm square. So the right answer is option A. Question number 70. If flowing through period of a sedimentation tank is 4 hours and the detention period is 9 hours, then the displacement efficiency is. Displacement efficiency is given by the ratio of flowing through period divided by detention period. So flowing through period is 4 hours and the detention period is 9 hours. If you calculate this ratio, the answer will be 0.444. So option A is the right answer. Question number 71. Combined correction for curvature and refraction for a sighting distance of 1.29 km in leveling is. Combined correction for curvature and refraction is minus 0.0673 d square, where d is the sighting distance in leveling in kilometer. So minus 0.0673 into 1.29 square, which is equal to 0.112 meter. Option A is the right answer. Question number 72. For a given torque on a solid circular shaft, if the diameter is doubled, then the maximum shear stress is. Maximum shear stress in a solid circular shaft is given by the ratio of torque divided by pi d cube by 32. By this relation, we know that maximum shear stress is inversely proportional to the cube of the dia of the solid circular shaft. So, if the diameter is doubled, the new shear stress will be equal to 1 by 2d cube, which is equal to 1 by 8d cube. So, it will be decreasing by a factor of 8 times. So, option D is the right answer. Question number 73. Amount of bleaching powder required daily to treat 3 into 10 to the power of 6 liters of water. If 0.3 parts per million of chlorine dose is required, bleaching powder contains 30% available chlorine. So, the amount of the chlorine required is 3 into 10 to the power of 6 is the quantity of the water treated with a chlorine dose of 0.3 parts per million. So, the total amount of chlorine required is 9 into 10 to the power of 5 kg. Amount of the bleaching powder is quantity of the chlorine required, that is 9 into 10 to the power of 5 divided by percentage of available chlorine. So, for 30%, the amount of bleaching powder required is 3 kg. Option B is the right answer, 3 kg. Question number 74. If the staff intercept is 0.2 meter, when the line of sight of a tachometer fitted with analytic lens with a multiplying constant 100, then the horizontal distance between instrument and the staff is. So we have to find the horizontal distance between instrument and staff. It is given by the formula D is equal to Ks plus C, where K is the multiplying constant, so 100, S is the staff intercept 0.2. Since the tachometer is fitted with the analytic lens, additive constant will be 0, so plus 0. Therefore, the horizontal distance will be 20 meter. Option A is the right answer. Question number 75. If the dry density of the sand with porosity 0.387 is 1600 kg per meter cube, then the void ratio is. Void ratio is calculated by the formula porosity divided by 1 minus porosity. So, porosity is 0.387, 1 minus 0.387, which is equal to 0.631. So, 0.631 is the void ratio. Option A is the right answer. Since they have given the dry density of the sand as 1600 kg per meter cube, we can also find the specific gravity of the sand by using this following formula. That is, dry density is equal to G into density of water divided by 1 plus E, which is equal to 1600 G into 1000 divided by 1 plus E. E is the void ratio 0.631. So, on solving this, the specific gravity of the sand will be 2.6096. So, this completes the part 2 questions of this question paper. I hope all the information and detailed solution provided for this question paper is satisfied for your examination preparation and as a reference for other civil engineering competitive exams. Thanks for watching this video. Thank you all.